All the participants will be in the same page. You already know some basics, that's fine. It will value addition, but purpose is that all the participants will be in the same page. In the second step, we'll move with different GCP inside. We'll talk about GCP fundamentals, features, GCP history, different category of services in the past, infrastructure as a service, software as a service, function as a service, container as a service, these models, right? In the third section, we'll talk about very important module, that is the security part. When I'm going to implement, when I'm going to use any service under GCP, first things that come into picture, how I'm going to implement security. So that security talked about using GCP IAM. Next, we'll move with compute services under GCP. Mainly, we talked about VM or virtual machine here. Next, we'll talk about another category of service that is called containerization side. How we can use, as you know, that you're moving towards cloud native applications. Think about any cloud, Azure, AWS, and Google Cloud. Applications are executed as a cloud native. So in case of cloud native applications, more 4 pillars, as you know, that microservice, container microservice we execute using DevOps culture, using CI/CD pipeline. And there, our GCP provided Google Container Engine have very importance, because this GKE, Google Kubernetes Engine, has very important service related to cloud native applications, a microservice deployment. That is another module we talked about. Next, we'll move with the serverless architecture. As you know that we're moving towards serverless architecture. So how the serverless architecture implemented in GCP using cloud function, app engine, or cloud run. These slides are slightly advanced, but we try to understand any one of the serverless architecture services under GCP, like cloud function or app engine, right? Next, we'll move with we'll talk about data engineering side. As you know that GCP has an excellent services to deal with big data. Big data services are there under GCP. As a data engineer, they always deal with AIML services or big data services under GCP. So we'll familiarize ourselves with different types of services in the category of big data side, in the category of AIML side. And next, we'll move with GCP storage services as an infrastructure as a service, GCP storage. If I want to store any image, files, audio, video, best option is to go for GCP storage. If the size is not too much big, then we'll move with some other services under GCP. Related to GCP database service, right? So these are the curriculum that we're talking about one by one. It's very good and excellent module, but our focus mainly based on this certification level. That's their curriculum. You can see here on the GCP side, we have multiple certifications. Basic one is the Cloud Digital Leader. Cloud Digital Leader certification category, it's mainly talked about familiarity with different services under GCP. So our focus will be this in the GCP essential curriculum. Though the slides are related to cloud engineers, but our focus is mainly this Cloud Digital Leader. certification, right? And you can see different categories of certifications are there, right? So that will come in this step by step. So these are the 3 points that we talked about. So good evening, everybody. Let's start our session today on GCP Essentials. As you know that GCP, Google Cloud Platform, this is one of the very important platform today that is a that provide a very good, excellent cloud solutions. So in this curriculum, if you move with this curriculum, these are different certification categories. But our discussion today mainly focus cloud digital level, cloud digital leader certification level, where we are familiar ourselves with different services. So we'll do some labs in this curriculum, right? So when you will familiar yourself with different services under cloud digital leader, then you can move towards cloud engineer, as well as different specific roles, right? Like cloud architect, cloud database engineer, cloud developer, data engineer, DevOps engineer, security engineer, network engineer, right? Fine. So let's move with this. It's a very good and excellent module. In this curriculum, before starting our GCP services, we know that different participants are from different skill set, right? So the purpose is that we will move in such way. First, we'll talk about some cloud computing fundamentals so that all the participants will be in the same page, and then we'll move step by steps with this. It's a very good, excellent module, and we'll do lots of labs. And I'll suggest you to do the same labs on the other side. Like this, we'll move next 5 days step by step. Fine. So first, we'll talk about cloud computing basics. What does it mean by cloud computing? Why, how this cloud computing come into picture? What is this cloud computing? Evaluations of cloud computing. Then we talked about how we can create a GCP account. And then we'll move to it different ways to connect with GCP. Since GCP is our main focus here, right? And then we'll talk about very important terms that is called capital expenses to operational expenses. Since you're moving from capital expenses to operational expenses, we talked about some concept related to region, zones, cloud computing delivery models, shared responsibility. So these topics are very specific, very prerequisites or very fundamental topic before going to cloud. And moving towards cloud first time, then we should have these basic points. We should have a clear idea about these points, right? That's why we say it's a cloud computing fundamentals. So let's move with this step by step. So we'll move, right? Fine. Okay, so I've just shared some of the images here. If you see, as I told you that today everybody or everyone leverage the cloud computing, regardless of job role, industry. Regardless of your job role or industry need employees to do the cloud computing. Earlier, just if you think about 10 to 15 years back, it was like, everyone should know Java, something like that, right? Same like that today, each and every resource in an organization should know cloud computing. It's an industry need, something like that. Why? I'm coming into that step by step. So if you see this slide, here we're talking about the definitions of cloud computing. What is cloud computing? To explore this, I'm just using this slide. So just see here, to run a car, you need electricity or gas, right? To run a web application, we need server, right? To run a home, we need power, right? So we don't create a power grid, right? We connect our home car with the power grid and consume the power from the grid. Then we pay the bill at the end of the month. So how servers are related to cloud computing? Right here, I've just given some picture of slide servers. So same like the power company, GCP, AWS, Azure, they supply the resource server to the IT companies. We connect the internet to set up the servers and its resources. So what does it mean by cloud computing? Cloud computing is the delivery of different services through the internet, including data storage, servers, database, networking, and software. So cloud computing will give you compute resources based on the demand that you have. So based on the usage of those cloud computing resources, you are liable to pay the bill to the cloud providers. As you are paying using the electricity and paying the bill at the end of the month to the electricity grid providers, same like that, as you are using the server or database or some other resources from the cloud provider, you are going to pay the bill at the end of the month. Right. That is cloud computing. Right. You are using the services, IT company using the services, storage service, database service, server, and at the end of the month, they're paying the bill. Right. Very simply, we define it as a cloud computing. Now, to understand this cloud computing well, we should have very good understanding about evaluation of cloud computing. If you get the idea, the evolution of cloud computing, we'll get a very good understanding about this. Let's go in depth. If you see here, if you see this diagram, it will tell you that first distributed computing came in the year 1950s. Then you'll find 1990s grid computing. Then you'll find 2004 Web 2.0. Then you'll find virtualization. See how the things came year-wise. But we should know the concept of cloud computing, how this cloud computing came, just we try to understand this concept from layman's language. Let's see the image. It will give you a very good understanding about this. If you see this image, see here. If you want me to make it big, I think it's visible, right? Okay. See, initially, think about our 10 to 15 or 20 years back, or 20 or 30 years back, when an IT company came in the market, what they do, or any organization, how they maintain their infrastructure is that any organization maintain their infrastructure, they maintain the hardware. Above hardware, they install operating system. And above operating system, they run the application. Like this way, they may have three major server. One is for development, another for production, another for testing. Right, like this way. So if you need some more server, what you do is that you buy some hardware from the market and going to add. So you know, so when I'm going to add some resources, we buy some resources from the market, some hardware from the market, and add with the existing setup. This is called vertical scaling. Vertical scaling means based on the load in your existing setup, to handle the load in your existing setup, you're adding some extra hardware from the market. So, right, so that is called vertical scaling. That we do it earlier. Any IT companies, they do it like that. They have their own infrastructure, they create their own infrastructure, right? Now, what is the problem? What are the limitations of this approach? Is that as the applications are growing, as the need of the customer is growing, they need more servers and more hardware infrastructure. Right? Again, you have to buy some hardware from the market and you have to include in the existing setup. Right? So, so this approach is being used. So what is the problem with this? As the applications are growing, as the need of the customer is growing, we need more servers and hardware infrastructure. That is vertical scaling, right? Now, to resolve this problem, the concept of virtualization came. What happened in case of virtualization? You have a host operating system. This host operating system, above this host operating system, you're going to install hypervisor. Above hypervisor, you're going to create a VM. And one VM, these VMs are actually using your host operating system resources. Above VM, you can create one VM for development, another VM for production, another VM for testing. Like this way, you can create. And if you are going to deploy some application inside a VM, it will run. This is how it is. This concept is called virtualization. Because this problem of adding extra hardware is resolved with the help of virtualization. So when your applications will run inside a VM, and when you find that huge load is coming, huge amount of customer request is coming in the deployed application inside your VM, what you do is that you will increase another one VM to handle that particular load. You are not adding hardware infrastructure. You are adding another one VM. So this concept is called horizontal scaling. To handle the customer load, to handle the customer request, you are creating another one VM and divide the request in between multiple VM. This concept is called horizontal scaling, adding the VM in your infrastructure, right? So each virtual machine, right? Now here, each virtual machine can be used for development, for production, or for testing environment or data, right? Now, what is the limitation of this approach? What is the limitation of this virtualization approach is that you can see that, see, business have to maintain their own hardware. Business have to maintain their own hardware, right? 24-hour power supply. If you see here that business have to maintain their own hardware, 24 hours power supply. They have to maintain, right? If more traffic. So the thing is that what is the problem with this approach is that this operating system, it has some limit. Assume it has storage some 2 terabyte TB. So it has some limit. Once and your VMs are using this operating system resources only. When that limit cross, again, you have to buy some hardware and increase your hardware, right? So virtualization concept that resolve to some extent, but ultimately once that load will is, again, you have to buy some hardware from the market, right? Then from here, you'll find next this problem is resolved with the help of cloud computing. So what you find in the cloud computing is that, see, what you find in the cloud computing, initially organizations provide database server, application server as a resources. Any company, they use those database server, use it and return it back. Stop it, right? Any company, they use the application server. Once it is done, then they'll return it back. That is how the business started. Cloud computing business started. Our GCP, they started the cloud computing business with the concept with App Engine. They're giving a deployment environment for deploying your Java and Python application. They started the business in the year 2008 like this, right? So initially cloud providers supply very minimal services like Linux server or Windows server or database server. But in the year, I believe in 2023, because the slide is created there, time. But now in the year 2024, now things are completely different. Today, businesses are dealing with big data, continuous flow of data, a stream of data. Think about our smart cities, think about our trading applications, think about our medical industry, think about our social media applications. Businesses are dealing with huge amount of data, continuous flow of data, continuous flow of stream of data that is flowing 24/7. How to deal with this huge amount of data? How to store this data? How to analyze this data? Right? So to deal with this data, today's cloud computing provide unlimited storage. Not only that, the data that is coming from multiple smart devices, it can integrate with IoT applications. It can analyze huge amount of data. AI/ML services can analyze continuous flow of data, stream of data. So today's cloud computing is in the completely different level. So for this, we have different category of services. Not only database service, by application server service or storage service, but also today's cloud computing can deal with unlimited storage, can store big data, can it can analyze huge amount of data using AI/ML services. Right, so that is the scenario why we are moving towards cloud today. Why industry want resources should be trained on cloud, because if you want to be in this level, you company want that the resources should deal with this huge amount of data using AI/ML services. We have different services under GCP. Resources should be trained on those services so that they can handle the company task without handling the infrastructure. See the scenario. When you're using the GCP provided services, you are not using these resources. Company is not going to handle these resources, right? Company just use the service, and once it is done, it will pay to the cloud computing provider. That's it. Right, so that is why company want that resources should be trained on cloud computing in the cloud. Even all the businesses are moving towards cloud. Right, so that is the scenario. The evolutions of cloud computing, initially it was vertical scaling, then you find virtualization. Now we are in the cloud computing side. Right, fine. Right. So this cloud computing, as I told you that AWS started their business, GCP also started their business nearby 2006. AWS started their business, GCP started their business in the year 2008. Okay, so this is the top two cloud providers started their business that time, right? So that is the evolutions of cloud computing. Now, when I moved with this, you can see that our topic is GCP, right? So So the point is that how to connect with GCP, right? So GCP will come step by steps, will come, but here we're talking about uh, how to connect with Google Cloud. There is 4 different approach to connect with Google Cloud. First is GCP console. Second is GCP Cloud SDK and Cloud Cell. Third is GCP Cloud API. Fourth is our GCP mobile client app. Right? So we can use, let's understand about these 4 types of connections with GCP. Let's understand. First of all, if I want to connect with GCP console, what I have to do is that I should have a Google account. And should use that Google account to connect once you logged in inside your Google account. Then, so if I want to connect with GCP console, if you see here, already I have connected. I just want to show you once again. I should have a Google account. I have already a Google account. So you have to just go inside this Google account. So I should connect with the Google account. Then we should log in the Google account. And then we should go here, Cloud Console. So if you have logged in the Google account, you can go to the Cloud Console, go to the console, and go to dashboard. You can see here all the services are there in the left side. I've logged in. So what is this? This is a simple web application. Console.cloud.google.com. It's a web application. You have just logged in inside the web application, right? So this is nothing but Cloud Console. We have to log in inside the Cloud Console. Okay. So that is GCP console. And you can connect with all the services, the GCP console. Right? Now, if you want to use any particular service, in GCP, you have to create a billing account. You know, different cloud have different criterias. If you want to connect with any GCP services, you can see all the GCP services in the left side. You can use the GCP services, but there is some conditional criteria is that you have to create a billing account. Then you have to create a project under billing account and enable it. These 2 tasks you have to do to connect with GCP. How to create the billing account? Just see here, I'm inside my GCP console. Now I'm going towards billing. Just see here, billing. I'm just see here in the left side. I have, see here my billing account 4. And to show you that if you're doing it first time, here I have to use create account. Here I have to use create account. So first you have to create a billing account if you're going to connect with GCP. So this is a billing account name, country, and you can continue. Once you'll continue, it will tell you to submit your credit card details. You have to verify yourselves with your credit card. They may deduct 2 rupees Indian currency. And once they are verified, they'll refund that amount in the next working days. This is how you have to create a billing account. So for me, I have already created a billing account. This is the billing account. You can see billing account 4. I've already created it and it is in the active stage. So that is the first scenario. You should have a billing account. Then you have to create a project under the billing account and you have to enable it. Then you have to create a project. So you have to go to my project, or if you go inside dashboard, you have to create a particular project. How to create a project? To create a project, you have to go to dashboard. In the right side, you'll find option called create project. So if you want to create any particular project, let's say I want to create one particular project, create. So this is, you have to create a particular project. See here it is saying a project created, right? So you have to create a particular project. Then under billing account, you have to enable it. Means you have to go to billing. On the left side, I have this billing account. Go to manage billing account. Go to my project. And here you have to enable the project with your billing account. Currently, this project is enabled, others are disabled. If you want to disable it, you can disable the billing. If you are not using GCP services, it is recommended that, or if you are using for training environment only, it is recommended that you should disable the billing account. Or you can do one thing, once if you want to use any specific project, so you can enable the billing account for your project. So assume I want to use a particular project, so you can enable the billing account for your project, right? So I'm using this. Select change billing, select the billing account, set account. So you can enable, you can see here for this project 319, billing account is enabled because all the services will run under your project. Right now, you can what you can do is that you can go here, go to dashboard, and here select the project for whom you have enabled the billing account 319, right? Where it is not visible. Let me just show once again. I have enabled the project. Good. Where it has gone. Okay, let me check once again. Here, payment here, and here I have enabled. It is so assume this is my project name. I'm going to do
You
this
need
is
to
the
check
project name.
ID, I guess. We were
Oh,
checking name.
Last
I'm
one,
going to
it was
check.
there.
It's okay. I'm just making it. I'm just enabling the billing account for this project 17322, and I'm going to disable as you wish because all the projects I'm not all the project that I have created. It's for training purpose only. So you can use this enable this billing account for any project. Fine. So this is my project name. See here my project 17322, right? So so when I'm going to use any service, go to the dashboard and select the project. This one, right? 17322. So select the project. Now I can use all the services under this project. Right? So under this project, all the services that is there, all services will work under this project. Right? So now I can use any services under GCP. That you have to remember, when I'm going with the GCP, you have to create a billing account and you have to create a project and you have to enable the billing account. Then only you can use GCP service. Else you cannot use a single GCP service. That you have to remember, right? That means this one that you're talking about here, that you have to Google account required, you have to register, and first you have to do the login. Once login is done, you have to create a billing account, you have to create a project, you have to enable the project with the billing account. That is just a slide here. I've just given the short. So assume my project 17322. I've enabled the billing account. My billing account name is my billing account 4. Right? Fine. Then the first option to connect with GCP. First approach or first option to connect with GCP. It's a simple web application. Just logging and you are connecting with the service. You are using a particular service. Second option to connect with GCP is Google Cloud SDK and Cloud Cell. See, what is this? Is that, see, the point is that if you want to work on Java application in your system, what you do is that you install one JDK, right? If you want to work on Python application in your system, what you do is that you install a Python JDK, right? Same like that. If I want to connect, assume the scenario that you have created microservice in your laptop and you want to connect your laptop with GCP. One scenario is that you can send that microservice in the GitHub, or you can send that microservice inside the GCP repository. So what I'm talking about is that if you have some code or if you have some file in your system, in your laptop, and you want to connect a GCP service from your laptop, you have to install one SDK. Its SDK name is Google Cloud SDK. Right? So if you want to install an SDK, what you have to do is that you have to go inside this link and Control V enter. You have to go inside this link. Okay, so the first, right, you have to go inside this link and you can see here install Google Cloud CLI. And if you go down, it is saying an option to install Google Cloud CLI installer. Right? So you have to click. Once you click see here, it is started. It's giving an exe. If you install this exe, it will install in your local system. Then from your local system, you can connect with GCP services. This is another one scenario. It is going to download, right? So this is another one option to connect with GCP. If you want to connect or to connect with GCP Google services from the laptop, right? This is one scenario. Second approach. Third approach is to connect with Google Cloud API. That already you know that all the services are exposing their services as an API. All organization exposing their services as an API. Similarly, GCP also exposing their services as an API. We'll talk about in depth after some time that how we can consume a service with an API. We'll have a very good and excellent lab for this. For the timing we're talking about that, whatever GCP services we have, all the services we can connect with an API. Right? Mainly developers use this. If you want to connect with an API, you can go inside this link, Control C, and you can see here Control V enter. How to connect with Google Cloud APIs? Right, and here we have excellent implementation. You can explore that part. We'll talk about later in details. Another one option is that to connect with GCP, we have GCP mobile client app. As you know that each and every application today we have app centric. Right. Similarly, GCP services also, if I want to consume from a mobile, I can do that. We have an app. You have to download that app from the cloud store, Play Store, and you can access all the services. Now, this is the link. You can just get some information related to that app. Control C. If you go inside this, Control V enter. You have to download from the Google Play Store, App Stores. And you can see here Google Cloud in a mobile app, product, alert, diagnose and fix issues. What they are saying is that the mobile app, all the GCP services are not available with this mobile app. What you're talking about here is that the main purpose of this implementation is that if any application is already running inside GCP and if you want to monitor the services, You want to monitor the services that is running inside GCP, then you can go with this Google Mobile Client app, because here all the services are not available. Main purpose of this GCP Mobile Client app is to monitor the services for your existing product, right? So next we're talking about, so we talked about 4 different approach to connect with GCP. Next, we are talking about capital expense to operational expenses. Means what? See that if you see here, the example that you're talking about, example related to our evolutions of cloud computing. So earlier, company have to create their hardware infrastructure. They have to maintain their hardware infrastructure. Now, companies don't have to maintain their hardware infrastructure. IT company just they use the services. Once it is done, they'll return it back or close or delete, right? So that you are talking about here. That you are talking about here related to capital expenses to operational expenses. So we are moving from capital expenses to operational expenses. What happened earlier is that asset purchased with a useful life beyond the current year. Ongoing cost to run a business. Lump sum upfront less earlier. Here monthly or annual recurring. So what you're doing is that in case of capital expenses, you buy hardware, operating system licenses. Business are in long-term commitment. Now we are moving from capital expenses to operational expenses. Not required to buy hardware or operating system licenses. No long-term commitment. Right? So that is, we are moving from capital expenses to operational expenses with this cloud computing. Now here, if you see, our topic is why GCP is so good. If you see this diagram, this will give you the complete range of GCP. See, GCP have a big infrastructure. World, 40% of the internet traffic is going with this Google network. GCP data centers are throughout the world. All data centers are interconnected using the GCP network. 37 regions throughout the world in 200 countries. If you want to get exact regions, then I will suggest you check here. This is the slide that you have done sometimes back. No, I want to see the exact number of regions. It was the slide when you have created that time. You can see you've written 40 regions, 121 zones. Let's see here currently. See here 40 regions, 121 zones. Correct data it is. They're not updated last 1 year, 1 month. So you can see here the complete network. All the regions are located throughout the world. Total number of regions is 40. The network, if you see here, how it look like, the network is located throughout the world, right? So that we're talking about here is that GCP has a very big infrastructure. 40 regions throughout the world. All data centers are interconnected using GCP network. right? 40% world, 40% of the internet traffic is going on this Google network. Now here, if you see, just now I told you two terms. One is called region, another is called zone. What does it mean by this? What does we find? Just now I told you that we have total 40 regions throughout the world and approximately 121 zones throughout the world. What does it mean by this? Right? Let's understand here. Regions, 40 regions. Regions means it is a data centers in a particular geographic area. So 40 regions means 40 data centers in a particular geographic area. Right? In India, you'll find two is there. The name of these regions will come in this format, West South 1. This is the name of a region. And total zones, it is saying 120 zones, 121 zones. It is the unit of isolations inside regions. And zone's name will come like this. You can see if the region name is West Southwest, West South 1, you can see the zone names coming as West South 1A, West South 1B, West South 1C. That means one region you'll find with three different zones, A, B, C. It is a standard. For one region, three zones. It is a standard. But in some specific country, they have for one region 5 zones, A, B, C, D, E. That is very specific to that particular country. Few countries they have, especially in European Union side, right? So, but the standard is for one region, there should have three different zones. And how it look like, if you see this diagram, it will give you very good and excellent idea. The region is called a data center. The region name is Southwest 1. We have three zones. See here, Southwest 1A, Asia West 1B, Asia West 1C. Three zones. You can see here, each and every zones are there inside this region. So assume this region is any location, it has three different zones. Now, what is the purpose of three different zones? If you see here, each and every zones contain rack. See here, this is called rack. Rack is a collection of node. This is called node. Node means servers. If you want to deploy your microservice, you are going to deploy your microservice inside this node. These are called nodes. Collections of node is called rack. So this is one rack, two rack, three racks. Collections of rack is called a zone. So inside a zone, you have multiple racks. Inside a zone, you have multiple racks. Inside a rack, you have node. Inside a node, you have deployed your applications. Now you can see here, inside these regions, why there is a three zones? Because the application that is running inside this rack, inside this node, its copy will be available in these zones also. One application copy will be available in another two zones to maintain the concept of higher availability. Somehow one zone is not available at a particular time, so the application will run from another copy of the application that is running in different zone. So you can see how these zones are created when these zones are created, right? So behind, there is they going to check that that when they're going to create a particular zones in such way that that particular area, that there should not have any power failure, or there should not have any natural calamities or terrorist activities. Now they are going to create those zones based on those criterias. And each and every zones have some different power supply. These zones have different power supply. These zones has a different power supply. These zones has a different power supply. They don't have the same power supply grid. That's why somehow if this zones is not available at a particular time, these two zones will support. These two zones will, give a, because the same application copy is available inside this zone, inside this rack, inside this node, right? So automatically, if this zone is not available at a particular time, same application copy is running here, right? So automatically it will support the client, right? That is concept of higher availability, right? That is the concept. We're talking about region and zones. How you can define regions? Regions, we say it is a data center in a particular geographic area, whereas zones, you know, it is an unit of isolation inside a region. You can say this is one unit of isolation, this is one unit of isolation, this is one unit of isolation, right? Fine. We're talking about like this way because ultimately we are moving in that particular direction. Okay, now we're talking about cloud computing delivery model. What does it mean by cloud computing delivery model? We'll find public cloud, hybrid cloud, and the private cloud. You will find these three types of cloud in the cloud computing delivery model. So what are these three clouds? Let's understand them well with an example. First, I'm talking about public cloud. Just let's understand using an example. What is public cloud? Share the computing resources with other platforms like GCP, AWS, Azure. They are examples of public cloud providers. Let me give an example to understand the concept of public cloud. See here, assume that Wipro, they need 1000 server. Assume. Eviden, they need 1500 server. Assume. IBM, they need 1200 server. Assume. So here, right, there is a need. Now, how this cloud computing provider will resolve that need is that from hardware A, assume from hardware A, using virtualization, they are creating multiple VMs. So assume there are 4000 VMs from the hardware A. Assume just naming convention. Out of this 4000 VM, 1000 is given to Wipro, 1500 to Evidian, and 1200 is given to IBM. So what happened is that all the organization, they are using the servers that is running in a single hardware A. That means that in case of public cloud, they share the computing resources with other platform or other tenants. Multiple tenants can use these computing resources from the same hardware. That is public cloud. Then what about this private cloud? Private cloud, it is saying that the entire infrastructure is dedicated to your organization. Examples of private cloud providers are like your VMware and Red Hat. They are popular private cloud providers. So assume, let's understand this private cloud using an example. Assume SAP need a private cloud, Oracle need a private cloud, and IBM need a private cloud. Though they have their own cloud, I'm just talking with an example for understanding point of view. And assume GCP is providing private cloud to these three organizations, or VMware is providing private cloud to these three organizations. How they will do it is that assume hardware B using virtualization, 1000 VM is created. From hardware C, using virtualization, 1000 VM is created. From hardware D, using virtualization, 1000 VM is created. Right? So this VMs is dedicated to SAP. These VMs is dedicated to Oracle. These VMs is dedicated to IBM. So that means what the entire infrastructure is dedicated to an organization. Or many VMs are there. All the VMs used by SAP only. Complete hardware, entire infrastructure is dedicated to one organization. Entire infrastructure is dedicated to one organization. This is private cloud, right? But that is not the scenario in case of public cloud. Same hardware, you have multiple resource servers, and that is being used by different organization in case of public cloud, right? Right. So that is the difference between public cloud and private cloud. Whereas in case of hybrid cloud, we say it's a combination of public cloud and private cloud. Few resources will be executed in the public cloud, few resources in the private cloud. So resources can communicate with each other, used by a secure organization, have the flexibility on expenditure, security, and protection. So that is, any organization, if they need, today, most of the organization, they prefer hybrid cloud. Based on their requirement, they use some services in the public cloud, some services in the private cloud, and they have the flexibility on and some services they try to use inside their on premises. That means, based on their requirement, they are going to use one service in a specific cloud, and that will have the flexibility on expenditure, security, and protection. Right? So that is the three different types of cloud that we're moving to the next step. In the next step, we are talking about GCP fundamentals, features of GCP, history of GCP, GCP product, GCP as a market leader. Here we try to elaborate this: PaaS, platform as a service, infrastructure as a service, software as a service, function as a service, container as a service. We should have very good understanding about them. Because for each topic, we'll do some hands-on, right? We'll do it one by one. Then we talked about what is this Google Cloud Platform, when GCP announced, why does GCP platform matters? Let's explore them step by step. Now here, if you see that features of GCP, if you see here, you will find that GCP Google Cloud Platform, they provided some services that are serverless. They provide AI services. They provide big data and analytics services. They provide services related to IoT. They provide services related to custom machine types, provide services related to scalability, cost effective. So whatever the services provided by GCP, each and every service has its own importance. If you want to analyze big data, GCP has a solution for big data analytics services. Excellent solution they have. If you want to use AIML, we have GCP provided AIML solution called Vertex AI. Excellent platform. Even it supports GenAI also. Excellent services from GenAI point of view also. Next, if you want to use serverless environment, I'll talk about this serverless. Serverless is same like your wireless. See, what is your wireless headphone? You can compare the concept with wireless headphone. See, if you have a wireless headphone, you are not managing the wire, but the connectivity is going on. Right? Same like that, serverless architecture, where you are not going to manage the server, but the application will be deployed in the server and run. This is called serverless architecture. It has an excellent history. I'm coming into that step by step. So serverless services provided by GCP to integrate with IoT applications. It has an excellent services. Then if you need any particular server from GCP, you can use a specific server based on your requirement that is said to be as compute services under GCP. Highly scalable and cost effective. Pay as you use point of view. Now let's explore more. Here we're talking about history of GCP. If you see here that the history of GCP, it started in the year 2000. You can see here, if you see here, Amazon have started Amazon S3 and EC2. Here you can see Google file system came, right? So here you can see the Google App Engine. So GCP started its business after Amazon in the year 2008, and they have started their business using Google App Engine. This Google App Engine, it's mainly initially it was giving a deployment platform for your Java and Python applications. Okay, then like this way, GCP has started its business in cloud computing platform. Then you find Azure also started, right? For initially, first, you know, this Google file system also very helpful to create or to connect with big data services in GCP, right? So this is the scenario, that came one by one. So we'll explore those things step by step. Now you'll find here different services are there on GCP. Lots of services are there. There you'll find some of the product. Some of the product related to storage. Storage means if you want to store some files, PDF, image, we will generally use cloud storage. But if you want to store some relational data, you go for relational database called Cloud SQL. So assume that relational, if you want to store the data that is in non-relational data, big data in this category, then you can go with Cloud Big Table, right? Similarly, if you see here, if you want to store the data in BigQuery or big data, if you want to store and analyze, you can go for Cloud Data Proc services. So these services related to big data, to connect with big data and to analyze the big data. BigQuery is also used to store the big data and to analyze the big data. It is one type of data warehouse service. Similarly, the machine learning platform. If you have the data and you have stored the data, or you have a deep learning model that is running in GPU and TPU, you can use Google provided TPU, right? And where your deep learning model is running, and that deep learning model you are using uh, for your Gen AI applications, or your AI company has their own AI infrastructure. For this, you can use the deep learning model. Provide the deep learning models are being trained with billions of parameters, right? So for this, you need a supercomputer. These TPUs are supercomputers. Okay, so you can use this TPU to run your deep learning models. We have cloud MLs. We have TensorFlow, right? These things, auto MLs. So if in your organizations you don't have data scientist, then also you can use GCP provided ML services, uh, um, to do the analytics. Right, excellent service provided by GCP. That is the main platform is our Vertex AI platform. Then we have here if this is the deployment platform. Deployment means initially GCP started their business with App Engine. It was giving a deployment platform for Java and Python application. Initially in the year 2008, I'm talking about. Now today this App Engine can be used to deploy uh, all lots of languages. All the popular languages you can deploy, languages applications you can deploy inside the App Engine. Right. On the other side, you can see here, as you're talking about that our industry is moving towards cloud native applications. Cloud native application means you want to deploy containerized microservice using DevOps culture, using CI/CD pipeline. And if GCP has an excellent solution that is called GKE, Google Kubernetes Engine. If you need any particular server to deploy your web application, we have a compute engine, right? If you want to execute applications as a serverless environment, you can use Google PubSub or Cloud Function, right? So we have different category of services are there, right? What we have to do is that we have to familiar ourselves with different category of services through hands-on, not theoretically. And we'll do in our curriculum, we'll do hands-on, right? Fine. So next, if you see here, you may find yes, AWS came first and it is dominating the cloud industry. Microsoft also dominating Azure, also dominating because lots of GenAI products you'll find, today Microsoft is implementing and moving that side. Yes, GCP also moving that side. GenAI solutions, excellent solution, GenAI solution from GCP you'll find from even AWS is also coming with excellent GCP GenAI solutions. So all these three clouds is moving fast in the industry. They are dominating, right? And GCP also has its dominance, right? So our curriculum is GCP. Let's move with that. So before coming into this infrastructure, I just now told you it's part of shared responsibility. Some of the responsibility is for cloud provider. Some of the responsibility is for uh, user. Now, how we can define these two types of responsibility? Some of the responsibilities for the user, some of the responsibilities for the cloud providers. How are we going to differentiate? Let's see this example. I'm coming into that. Let's explore this part first. PaaS, platform as a service, IaaS, infrastructure as a service, software as a service, function as a service, and container as a service. We should have a very good understanding about this. Let's explore this part. Then I'm coming into our own GCP Global Services. So just see here, first we are talking about container as a service, CaaS. What are this? See, all the GCP services you can put inside these five categories. All the GCP services, right? So, but we should know, we should have a good understanding about this. Let's talk about in this theoretically. Let us just get some idea. Then all category of services we try to do hands-on. We'll do hands-on for all category of services. So first see this container as a service. What it is saying is that you can see here a container is a set of application files, dependencies, configuration needed for runtime environment. Just now told you that we are moving towards containerized application, cloud native applications. In cloud native means what? Cloud native contain four pillars. Web containerized applications, microservice, DevOps, CI/CD. So when I say container, what we do is that we create a containerized application. That container is a set of application files, dependencies, and configurations needed for runtime environment. GCP CAS is built on open source Kubernetes system. Kubernetes is a container orchestration tool. Kubernetes is a container orchestration tool. Now, GCP CAS run on multiple platforms like on cloud, on premises, or hybrid cloud. So, so you know, so CAS, container as a service, means our Kubernetes can create multiple container, and at the time of load, it can supply multiple container. How it is, just see here. Let me give some example. I'm talking about this. I think it has gone. Okay. So for the timing, I'm just moving with this container as a service. Now let me just talk about CAS. Let us give an example. Let's see here. Let me give some idea. Just now I told you that cloud native application. I'm just using the term because industry is moving here. Complete industry is moving here. Cloud native application means microservice plus container, container as microservice, DevOps culture with the help of CI/CD pipeline. So these four together is called cloud native applications. Fine. Now assume you have a microservice. Name of the microservice is customer microservice. Microservice is called independent deployable component. When you create any particular microservice, you can create a microservice using Spring Boot, or you can create a microservice using .NET also. So each and every microservice has its own server. Each and every microservice has its own database. So server means it is running in a port number as 8081, and it is using a database DB. Right now, this microservice, it is said to be as a containerized microservice like this. I'm not saying like this. Assume this microservice you always as a containerized microservice. Now, when the customer request is coming, assume at a particular time, you find 100 request, customer request is coming to this microservice. Now, what you do is that Kubernetes, when huge amount of request is coming to your microservice, Kubernetes is creating multiple instances of the same microservice. This is called scale up. And when huge amount of number of requests is less, when number of requests is less, automatically it will reduce number of instances. That is called scale up and scale down. We define it as an auto scaling. This scaling up and scaling down happen simultaneously based on the customer load. And that happened with the help of Kubernetes. Kubernetes is the container orchestration tool. It can orchestrate multiple. Orchestration means what? What is orchestration? Orchestration means, I'm just talking about, it is said to be as a container orchestration tool. Container orchestration tool. What does it mean by orchestration? What is the meaning of this orchestration? Orchestration means, assume, let me give an example. You are listening a very sweet song, melodious song, or you are listening a very good hip hop song, right? So all the sounds are coming in such a way that, all the sounds are coming in such a way that, right, that it will give you a very good melodious song or an excellent hip hop song. Right, it's combinations of all the sounds so that you'll find a melodious song or hip hop song. Excellent, right? That is called orchestration. All the sounds are orchestrated in such a way that it is going to create a very sweet song. Same like that, when you have multiple containers based on the load from the customer side, Kubernetes can create multiple containers to handle that particular load, or reduce number of containers based on the load that is coming from the customer automatically. That's why Kubernetes is called container orchestration tool, right? And this happened in case of GCP with the help of Google Kubernetes engine. Right? So this CAAS is said to be as container as a service. Mainly internally, Kubernetes come into picture. Kubernetes is the container orchestration tool who is going to increase number of containers or decrease number of containers during runtime based on the client load automatically. Right? That is the idea behind CaaS. In GCP, the CaaS service is Google Kubernetes Engine. Just remember the name, we'll talk about it later. Right? Fine. So next we'll talk about another one important service called SaaS. Now SaaS full name is Software as a Service. You see the name? Its full name is Software as a Service. And the question is that what does it mean by Software as a Service? Right? So just see here. Uh, let me give an example of Software as a Service. Is our Gmail, or is our Google Drive, or Google Workspace. These are the example of Software as a Service. See, what he's saying is that what you do with the help of Google Drive. If you want to store some file, just log in the Google and store the file in the Google Drive. If you want to download the file, just log in the Google and download the drive file from the Google Drive. Right? So Google Drive, what you doing? User not aware about the cloud provided software used in the process. Everything is hidden from the user. What is going on back end? How this Google Drive is maintained? User is supposed to use cloud-based apps over internet. So that is software as a service. Our Google app like Gmail, Drive, ready to use services. So if you want to see this software as a service, just now I have given one diagram. If you see this diagram, see this, sir. In case of software as a service, all responsibilities is a Google responsibility. Deployment, see, all these responsibilities are the Google responsibility. What is the user responsibility? Access privilege. If you just put in any file in the Google Drive and give access to an email ID, only that email ID can access those files. Right? So access privilege part, right? That you're talking about a SaaS, right? So in case of SaaS, or software as a service, right? In case of SaaS software as a service, the complete things 90%, 95% is the Google responsibility. So with this SaaS service model, the service provider deliver the entire application stack, the complete application and all the infrastructure needed to deliver it. As a customer, all you have to do is connect the app using an internet. The provider is responsible for everything else. Right? Okay. So till I just talked about this, we'll explore more SaaS after some time next day. Now let's move to the another one that is called PaaS. So full name of PaaS is Platform as a Service. Okay. So Platform as a Service means what? Let me give an example. Like the example, let's take the App Engine. App Engine is a deployment platform for Java and Python applications. That is how GCP started their business. GCP started their business to deploy Java and Python applications in the year 2008. That is an example of PaaS. So what is PaaS? PaaS provide a platform on which applications can be developed and deployed. PaaS providers abstract much of the work of dealing with servers. PaaS providers give clients an environment in which the operating system and server software as well as underlying server hardware and network infrastructures are taken care of. Users are free to focus on business side, application development of their product. So if I want to say the examples of PaaS solution is Google App Engine. Google App Engine, we have Cloud Run also an examples of PaaS solution. So the question is that how this PaaS work? If you see in case of PaaS, just see this diagram. Just now I told you this diagram, right? If you see this diagram, PaaS. See here in case of PaaS, platform as a service. These are the Google responsibility, and right? This is the user responsibility. So in the user responsibility, you'll find deployment, web application security, usage. So in the PaaS, given a platform, user can come and deploy the application in that platform and use it. Right? That is PaaS, and that you're talking about here. Right? Google App Engine. Now the point is, what is the benefit? Yes, I'm taking this is called PaaS. It's fine. What is the benefit? Most common benefits of PaaS is like faster time to market, low maintenance, cost-effective pricing, easy scalability, right? Then you can say flexible access, shared security. These are some of the things that comes. If I'm going to use, let me say faster time to market, right? You don't have to manage your setup. Just use the deployment platform. Once it is done, just delete it or close it. That's it, right? You faster time to market. You don't have to manage your setup. Not only that, low maintenance, because cloud providers are giving you pay as you go policy. The time you have used, you have to pay for that particular time itself. And their cost effective pricing, easily scalable. When you're going to use any particular service, right? As I just now told you, that when huge amount of load is there, but your applications will be scalable. Shared security, complete security will be applicable in your past product of Google App Engine also, right? This is the advantage, right? Why you're moving towards this path. Next example is called infrastructure as a service, or IaaS. Example of infrastructure as a service, like you want to take a server, right? And that server, you want to use it, and after that you want to return it back, right? So when I say infrastructure service, means is the bottleneck support by the cloud services. Cloud provider rent their server in infrastructure service. User need to pay based on their usage, the infrastructure. Users are free to use OS software based on the requirement. They need not worry about hardware and data center management, right? So examples is our compute engine, GCP compute engine, where you're going to get some services, virtual infrastructure like VM, networks, etc., provided by GCP compute engine, right? GCP storage, right? This also comes under infrastructure as service. Now the question is that why you're moving to this? It is economical. Just you don't have to create your own infrastructure, right? You need a server, create the server, use it and return it back. It's efficient, boost productivity, pay as you go policy, scalable, and it derives faster time to market. right? Fine. Next one is called FAS. This is an excellent solution that came in the market. Just now told you that what is FAS? Full name is function as a service. First time, it is the concept of serverless. Means what? Means, see, if you want to deploy your web application, what you do is that you deploy inside a server, you start the server, then the application is running. FAS is saying that you don't have to manage the server. You don't have to manage the server. That is FAS. Means same like your wireless headphone. When you're using your wireless headphone, you are not managing the wear, but the connectivity is going on, right? Same like that. In case of FAS, you are not managing the server, but your deployment is done. That is FAS. So this first concept, first time came. It's based on event. So first time this first concept came in the year 2014, based on some convention in Amazon. Okay. So first time this concept came first, function as a service. After that, different cloud, they have implemented this first. GCP also implemented this first, and lots of services they have created using first.